Hey everyone! Alright, I got a example problem here for vector math. This is, well, let's read it and then we'll talk about what kind of problem it is. If A equals 10 I hat minus 4 j hat and B equals 3 I hat plus B sub y j hat. So we don't know what that one is. That's a placeholder. That's a variable. Find the value of, it'd be good if I wrote that in. That's supposed to say B sub y, which will make B orthogonal to A. So what can we use to figure this out? Now we could draw it out, we could try to figure it out, but we have a really useful tool for orthogonality, which you may or may not have realized, and that is the dot product. Remember, the dot product is the multiplication of one vector with another such that, say, the first vector, for example, portion of it in the direction of the other vector is what's actually multiplied. So that means if they're parallel, it'll be just a multiplication of the two vectors' magnitudes. But if they're perpendicular, then no portion of the first vector is in the direction of the other vector, or vice versa, so that the dot product will equal 0. You see this in the AB cosine theta version of the dot product as well, because cosine of 90 degrees is 0. So what we can do is just perform a dot product, set it equal to 0, and solve for by. And then we will have whatever component needs to go here for them to be orthogonal. Okay. So the dot product equals 0 when A is perpendicular to B, because if I draw two vectors that are perpendicular to each other, you can see that if I were to shine a flashlight from up here at it, the projection of A onto B is nothing. There's nothing in the direction of B. So if I've drawn B as though it was in the x direction, so there's no x component to this A. It's all in the y direction. If that is the way I define my reference frame, define that as x and this is y, then you'd see nothing is in the x direction for A, so that when they're perpendicular, the dot product will be 0. All right, so then we're just going to set up our dot product. 10 I hat minus 4 j hat dot 3 I hat plus by j hat equals 0. Whatever b I solve for from this equation will force this vector to be perpendicular to that vector because I've set the result to be 0. So our dot product, 10 times 3 plus minus 4 times by equals 0. All right, so 30 minus 4 by equals 0. So that, probably starting to get to the end here, slide it up. By equals minus 30 over minus 4, which is 30 divided by 4. And I could, in physics I have a tendency to just switch these in class to decimals, but let's see, we can just at least make it 15 over 2. Oh, that is 7.5. All right, so we know what it should be. And if we want, I suppose we could, what could we do to test this? Could see if those vectors are orthogonal. Really, the best way is to do the dot product. We can draw it and see if it looks reasonable. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I never make it long enough. And 1, 2, 3, 4 ish. Better if I did this on actual graph paper. So that's there. That one's A. And then B was going to be 3. B would equal then 3 I hat plus 7.5 j hat. That would be our B. So we're going to go 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8. 8. And it's about halfway. And 3. Right around there. Well, within the error of my hand-drawn system, that looks pretty orthogonal to me. So I'm going to say this seems quite reasonable, and we will leave it as done. All right, see you guys next time.